and welcome back to the Application Architecture Summit breakout sessions. This is the session for Red Hat OpenShift, and joining us again, Brian Gracely, Senior Director of Product Strategy for OpenShift. Brian, welcome.
Thanks, Vance. Appreciate it. Good to be here.
You know, we're really glad to have Brian with us this morning. He drives strategy and implementation for how OpenShift delivers for DevOps and cloud-native app delivery. He may be familiar to some of you as he is the co-host of an award-winning podcast, The Cloudcast, and a weekly Kubernetes podcast. He brings 20 plus years of experience in product management and strategy and, of course, app architecture to his post, and we're going to all benefit from all of that this morning in Brian's session, Cloud Native Development in a Hybrid Business World. You know, we all know that app makers just can't build or deploy apps fast enough to keep pace with business demand. And Brian's going to help us out here with his session. He's going to talk about how the Red Hat environment is making cloud app innovation much less complicated by bringing together platform, developer, and application services technologies in a really great way to help leverage automation and abstraction. That'll help developers and architects and other stakeholders get apps faster to the business and let business communicate better to the IT and development environment. So before I hand it to Brian, let me just remind you, he's brought a number of terrific, valuable assets with him. To download his slides, you can just click the big red button on the view screen, and to click of any of those other assets, you won't need to register. You did that to join us this morning. To talk with Brian, just hit that submit a question box button. So with that, Brian, let me turn it back to you and tell us about cloud native development in a hybrid business world.
Great. Thank you very much. And thanks everybody who's joined today or might be listening later. So I have an opportunity as part of my job at Red Hat to not only work with the product team to deliver a number of technologies around application development, but I also get a chance to speak with a lot of different companies around the world, application teams, infrastructure teams, the leadership teams. So what I thought I would do today is try and share some of the lessons we've learned from those different teams and try and put some perspective around why, after a decade or so of a lot of really interesting innovation and technologies, maybe certain teams and certain companies are moving faster than others, and what can we learn from the teams that are doing really, really well versus some of the ones that still struggle. So it's been nearly a decade since we all started coining this mantra that software is eating the world. I think we've all seen this in every aspect of our lives, whether it's the devices we use, the way we interact with different companies and businesses. And I think it's a pretty well-received idea that the things that are really impacting companies that are successful, new successful ways that we interact with businesses and with our communities and so forth are all very much software-driven. They're in a world where not only is software the center of it, but the rapid iteration, the number of features that are coming in, the velocity at which we're able to make changes to that software and use the data from that software to make decisions is really become very much a part of what we do on a daily basis. Now, the thing about this is we've also heard for many, many years now that developers are the new kingmakers. We've been hiring developers, we've been training developers, we've been adapting new types of systems to help them to build faster, to give them more data at their fingertips. And so, you know, we really have the possibility that if our businesses are more focused around using software, around using technology at the center of how we interact with the marketplace and how we make decisions, that there is a huge opportunity to really take advantage of what's going on in your market to differentiate your business. And so you put those two things together and you go, boy, the technology's out there. There's motivation in the market to do this. There's obviously profits and revenues that are available, but why isn't everybody as far along as maybe some of the big names that are out there in Netflix or somebody else? And it really kind of asks the question, you know, why do we see development teams sometimes still being frustrated? Developers saying, I don't deploy multiple times a day, or I don't get to use all the tools that I want to because my business has certain restrictions, certain requirements, certain security things they have to do. You know, why don't we have this sort of perfect scenario where if to make our business better, we have to be using more software, we have to be developing software better? Why isn't every business made this sort of a core competency at this point? And we're going to throw out a few theories about why we think this is the case. And also we're going to talk about how Red Hat's been trying to put certain things in place, technologies in place, platforms in place to hopefully get a lot of application developers past this frustration point. So I think the first thing that we have to think about, maybe not immediately as technology, but let's talk about kind of at a business level, why do we have the need to be more software centric in business, but also why is this sort of complicated? Why is this not just a straight line from software's eating the world, developers the kingmakers. Let's all go out and be wonderfully successful and profitable. And I think the first thing that we very much see is that today's businesses, the largest businesses, the medium-sized businesses in every industry and every geography, for the most part, are hybrid. The world hasn't moved entirely to one mode of operation, one mode of doing business. We still very much have to be able to accommodate direct and physical interactions, whether this is at a store or some other sort of physical locality, something that has a physical aspect to what we do, face-to-face interaction. We still have to be very, very good at those types of interactions. Locality in many cases matters. Second, we do have more and more of what we do that are digital engagements. This is an app on a phone. This is a kiosk. This is a website. Very much the interaction is you interacting with an application, you interacting with a website, your partners working together through digital interactions. And then the third mode that we often have is that we don't have any direct interaction. We're actually interacting with marketplaces and APIs in which we're able to bring together a lot of knowledge, a lot of data, a lot of different parts of interactions together into one experience. And so when we think about the way that our software is now interacting with the marketplace, we have to be cognizant that all three of these modes happen all the time, and that these three different modes oftentimes mean that we have to build around different scenarios. We have to build around human interaction, device interaction, marketplace interaction, or API interaction. And being able to do those all very, very well often means we have to introduce a set of complexities in order to be able to take care of making sure they're all secure, they're all compliant, and there is location involved. We take that into consideration. The other thing that is often sort of challenging for developers to kind of wrap their head around is that while we talk a lot about application developers being successful, applications driving the business, data driving the business, we also have to realize that you need to get a number of people involved, a number of different groups involved, in order to all be marching down the same path, all be rowing the boat in the same direction, all having the same motivations. And in many cases, this involves a lot of different teams. And I don't mean to bring this up in terms of, hey, complexity happens, there's nothing you can do. I think having a realization that these different groups are all in different ways trying to make the applications more successful, trying to make developers more successful is important. But it's also important to understand that you can't just work in a silo. You have to be working with these teams. And it's important that as platforms are being selected, as technology is being selected, that there's some cognizance that these different groups have a specific role to play, and an important role in many cases. So what we tend to see as we talk to companies out in the world, there are many groups where they tend to fall into these four buckets. You have infrastructure and operations teams who are trying to put together the best platform possible for application developers. They're trying to take friction out of the way, but at the same time, they're trying to make sure that they can fit into systems that will be scalable, that they can interact with maybe existing systems they have in place. Obviously, developers want as much friction taken out of the system as possible. They just want to write applications. They want to write code. They want to push code. They don't want to worry about the infrastructure, but they have to be, in some cases, cognizant of what are some of the choices that the infrastructure team made. What does that mean to them? Maybe it's a security thing. Maybe it's interacting with a firewall. We also have to be aware that there are architecture teams that are being given the mandate that says, we want to be able to work in any cloud environment possible. That could be a private cloud environment. That could be a public cloud environment, multiple cloud environments. And this is being done partially for business reasons. We want to be closer to our customers. We want to be closer to the partners that we work with. In some cases, they're for competitive reasons. We choose a cloud based on who we're going to work with. Are they our partner? Are they a technology provider? Are they a potential competitor? And they also are taking care of, they're trying to plan for the future. They don't necessarily know what's going to happen. They're trying to plan for the future. They're trying to make sure that the investment they're making will be future-proof for 3 years, 5 years, 10 years, whatever's appropriate for the business. And then finally, you have leadership within the business of various technical background, really trying to understand, where do we invest? Where do we invest in people? Where do we invest in technology? If we have culture that maybe isn't yet adaptable to these more agile environments, what do we have to do to be able to be adaptable? When do we have to hire differently? When do we have to train differently? When do we make different technology or partnering choices? And so all of these things are realistic concerns and realistic elements of ultimately making those application teams successful, but also making sure they're secure, that their data is going to be protected, that they're making investments that will be viable for the short term and the long term. and making sure that they can still continue to operate the business with including the applications that make them successful today. So as we take all these things into consideration, I want to talk a little bit about how do we move forward from maybe some of that frustration that application developers have to a state where we're providing them the technology and the tools, as well as for those other teams to make consistently all those groups successful. Again, getting the entire business moving in the direction of building great applications, collecting data about them to make them improved, and also ultimately to deliver great business experiences for your end customers or your partners or your marketplace. So one of the questions that comes up quite a bit is there are so much innovation that's happening right now. This picture in the background is a diagram that comes out from the Cloud Native Computing Foundation. It's really a map of all the different projects, innovation projects that are happening in open source, that are happening around sort of the cloud native landscape, if you will. And a lot of times people are on the fence. Is there great innovation that's able to help them, things that never existed before? Or is there too much innovation? I can't choose between one of 10 different new pieces of technology that all sort of seem to solve the same problem. And this is really a trade-off that a lot of companies are kind of forced to make, is trying to figure out, where do I go get innovation? Do I invent it myself? Do I work with an open source community? Do I work with something else? And then when I find the thing that I really want to work with, how do I make sure that we're trained up on it? We have people that have that skill. And so what we try and do at Red Hat is help you sort through the innovation, help you find the best of the best, if you will, but also bring it together in a way that a lot of those frustrations that maybe groups have between different groups, picking and choosing, dealing with interoperability, trying to make it secure, we bring those together in one consistent way. And so we're going to talk about that for sort of the second half of the session here. The way that we go about bringing that together is in a platform that we call Red Hat OpenShift Platform. The way that we like to think about this, and the way I'm going to describe it, is sort of in two pieces. This is all one consistent platform, but think about it as sort of two pieces. The bottom piece with the red dotted line around it is what we really consider the infrastructure part of the platform. This is the pieces that are going to interact with any of your cloud platforms. So it's very important that this platform will run consistently on any cloud around the world, whether that's your private cloud or bare metal, whether that's a public cloud, any of the major public clouds, or can be delivered as a managed service through Red Hat. So we want to give you a consistent platform for everywhere. And then what we deliver on top of that core platform, we're going to talk about in terms of application services, developer services, and the things needed to make sure that the applications run highly available, secure, and highly performant. So we're going to spend most of the rest of the time today really talking about those two middle sections. What are the platform services that will make developers successful? And what are the application services that are going to be there and native on the platform that developers can just take advantage of to make their applications scale, to integrate them with other applications, and so forth. Now, people are sort of surprised sometimes when they think about what's available to me as an application developer to be successful. The good news is there's a lot of things available to you. Everything from things that are going to help you get your applications up and running, CI and CD pipeline services in order to be able to write code, test code, push it through integration, and ultimately get it out into production. And then a number of other things that are going to help make sure that you've got great visibility into what's going on with your application. You can see the interactions that are there. As we begin to build more modern types of applications, how do we make sure that the interactions between microservices are done in a properly network segmented way, that they're securely taken care of, that we can trace them, and so forth. And we want to make sure that all of these things are going to be immediately available to developers as part of the platform. So as we think about the platform itself and sort of these things across the top, those are all services that are natively part of the OpenShift platform. They are there to make sure that you as a developer, whether you have an existing application you're trying to modernize, you're trying to build new microservices applications, or even you're dabbling with sort of the latest and greatest in things like serverless, those are all just natively available for you. Red Hat had to do a lot of work, not only in terms of helping to develop those technologies in the upstream open source communities, but bringing those together so that when it comes time for application teams to build their applications, they don't have to think about integrations. They don't have to think about what to pick and choose. They're just getting the best of the best natively in the platform, fully integrated, and just they can go to work, go build your application, go be successful with the business. So let's dive into that a little bit more. So as we think about what Red Hat OpenShift does for developers and application teams, At a really, really high level, if we're just talking about sort of headlines, there are a number of things that we think are really crucial to be natively part of the platform. The first thing is I want to make sure that the platform supports a very broad set of applications. This means that I should be able to support everything from an existing application that I just want to modernize into a container that I could run anywhere. This could be an existing Linux application. I want to make sure that as we're working on microservices using whatever languages and frameworks that make sense for you, whether that's Spring Boot or something more modern, I should be able to bring that and run that on the platform. And then I should also be able to do really more modern, cutting edge types of things like AI and ML on the platform. And you should be able to run all of these applications highly available, highly performant, without having to build sort of a silo for every different type of application. So we spent a lot of time making sure that a broad range of applications will run on the platform. We want to make sure that the platform can be run as self-service. We want to take that friction for developers out of the equation, give them access to self-service tools, self-service languages, runtimes, basically all the services that you want to get access to without having to go and ask, without having to open a ticket. And so this is not only self-service for the developers, but also a broad ecosystem marketplace of new services that they can just get to with a couple of clicks. We want to make sure that it's easy to bring your CI/CD pipelines or just work with native CI/CD pipelines. So you write code, you want to be able to test it, you want to be able to validate it. CI/CD pipeline should just be a click away and be able to plug into your Git repositories, your source control, your testing system. So those are all natively part of the platform. Middleware services we're going to talk about in a little more depth and detail in just a little bit. And then things that are beginning to make a lot of noise in the industry. So things like Service Mesh, which is helping us provide network isolation, provide secure communication between microservices. Again, these are native part of the platforms. You don't have to, as a developer, set them up. You don't have to think about them. They're just there and readily available to you a couple of clicks away or a couple of API calls away. And so we're going to get into more detail about what all these things mean. Now, the first thing that we've learned over time in working with a lot of different companies and a lot of different developers is that there is no one single profile of an application developer. In fact, there's usually not even one single profile of an application development team within an organization. There's often lots of different opinions, lots of different requirements to use different tools. And ultimately, what we've learned is the more restrictive that you are with developers or with the tools they have access to, the more frustrated they get, the more likely they are to kind of work outside the process, work outside the box, potentially create some bad situations for the company in terms of security, in terms of data breaches and things like that. So we want to make sure that the OpenShift platform supports not only a lot of different kind of perspectives on how developers can be successful, but also integration with the tooling that you're comfortable with and that is going to make you successful. So we've worked very, very hard on making sure that OpenShift supports native developer tooling. So there are native tools within the platform. There are CLI-based tools, there are API-based tools, but also we integrate with a number of the tools that you use all the time. So things like VS Code, Azure DevOps, Eclipse, JetBrains, the IDEs that developers want to work in. So OpenShift very much has an opinion that we want to be flexible about how we can work with you. We want to plug into the tools that are native with developers, and we want to make it flexible so that within a given team, you can pick and choose things, but maybe some other team within your organization can pick and choose something else. We want to make both those teams very, very successful. Now, let's go a little bit deeper and look at some of these in depth. Now, when we talk about IDEs, one of the things that Red has been working on quite a bit is something we call code-ready workspaces. This is based on a project from the open source community called Eclipse Che. And this allows us to have a developer on day one come up, point to a URL that the platform has defined for them, and allow them to have a web-based browser or IDE within their web-based browser come up, fully integrated with their source control, fully integrated with their CI/CD pipelines, and fully integrated with a set of collaboration tools to allow them to work within their team. So this is oftentimes a very first starting point for developers is bring up a browser, your IDE is within the browser, you can begin writing code, pushing code, and all of the backend services are automatically integrated for you. So this is a very nice, clean way to get started with the OpenShift platform for developers on day one, or potentially even remote developers or contract developers that you want to just make successful on day one. You don't need a lot of customizations, and you just want them to work within sort of the framework of the platform. The second thing we want to make sure that we can provide for them is visualization. We're getting into more and more complex integrations, more and more points of integration. And so within OpenShift, there is a distinct console for developers. So as applications are built and deployed, as they change, not only do they have browser-based tools to help them be successful, but also visualization tools to make sure they understand how do these things interact with each other? How do we label them and tag them so that if we have to make changes, that's very, very easy to do. So within the platform, great visualization for all of those applications. The third piece, and we talked about this a little earlier, was native pipelines. So one of the great things about OpenShift is that it's built on a scalable platform. It leverages Kubernetes, which really understands how to scale very, very well. And so more and more we're seeing people say, hey, my CI/CD pipelines run, in some cases, need highly scalable environments. In some cases, scale it down to zero. But I'd like to control that a little bit more. I want to just run my tests when I want to run my tests. And so the CI/CD pipeline capabilities are built into the platform. They allow you to quickly spin up a pipeline, have visualization of what's going on within that pipeline. You can see where things succeed, where they fail. And if you want to, you can put gates and notifications to other groups if they need to allow things to pass to the next stage of your software supply chain. So having the CI/CD pipeline natively integrated, really, really powerful for allowing developers to do essentially self-service development of their applications. The next thing we talked about was, well, that's great that all those tools are built into OpenShift, but what if we want to use tools that we know and love that aren't OpenShift? Well, this is where we go and reach out, meet developers where they are. So we've done a lot of work. I'm just going to highlight one of them with VS Code. The integration that OpenShift does with VS Code has been downloaded millions of times. VS Code is an incredibly popular development tool. And so what this does is within the VS Code environment itself, it allows them to not only write their application, but sort of give it some hints and some integration points for integrating with OpenShift and Kubernetes to really get the power of the platform brought to developers' tooling. And so again, us from Red Hat meeting developers with the OpenShift platform into the tools that they're used to, things like VS Code, and I mentioned some others, JetBrains and Eclipse and Azure DevOps as well. The next thing that's really important to understand is you wrote your application. In many cases, you want to take advantage of other services that might be available to you. So these could be languages, runtimes, this could be business logic. And so Red Hat provides a full suite of middleware services, API gateways, integration services, Java services that are available to help expand out your applications, build them, scale them, integrate them with other things in your business. These are native services of OpenShift that can be added to the platform, run natively on OpenShift, run as well with your applications, and really help them grow from just your application to a much broader way of impacting the business. The other thing that Red Hat has done as part of the recent acquisition by IBM, just like we have the Red Hat suite of middleware services are available, the full IBM suite of middleware services that are now called Cloud Paks will run natively on OpenShift. So for companies that are familiar with IBM middleware, that leverage it to run their business and power their interactions with the marketplace, all of the IBM middleware services, now known as Cloud Paks, will run natively on OpenShift. And this means that because they run on OpenShift, not only do they get the scalability of OpenShift, the security of OpenShift, but also it means they can run anywhere on any cloud. And so this, again, becomes very, very important for companies that are trying to make sure that they meet the marketplace where they are and that they're doing the best integration they can with their marketplace and their customers. So a very, very broad set of middleware services can also be brought to those new applications that you're building, leveraging the native capabilities of OpenShift. Finally, one of the biggest and hottest topics out there in the marketplace today is AI and ML, the ability to take all the data that you're collecting from your applications, potentially from your marketplace, from your customer interactions, and being able to use those more intelligently. So we've been working very, very diligently with a really broad ecosystem of companies and technologies to make sure that they run very well, first and foremost on Kubernetes, as OpenShift is built on Kubernetes, but also then making sure that those are certified to work on OpenShift and they can be secured and scaled appropriately. So this just gives you a sampling of a number of the AI and ML applications and frameworks that run very, very well on OpenShift today. There's a lot of work going on to continue to improve these, but I wanted to give you a sense of if you're working in that space, and almost every company these days has some sort of project around AI and ML, you can feel very comfortable that they are going to be supported on OpenShift. They are going to be scalable on OpenShift, and they allow you to run them on any cloud platform that you want to, because OpenShift runs everywhere. So whether this needs to be on premises or in the public cloud, you can take advantage of those services on OpenShift. Finally, there's a really, really important technology that's been evolving over the last year and a half in the Kubernetes space. And again, if it runs on Kubernetes, it runs natively on OpenShift. And this is a technology called operators. And what operators do in the simplest terms is it takes a more complicated application, oftentimes databases, queuing services, storage services, lots of different things that you would like to run, and it essentially turns them into an as-a-service service that will run anywhere. So you want a database as a service, a message queue as a service, Kafka, something else as a service. What you're looking for is there an operator built for this? And operators basically take the knowledge that a normal human operator would have for running that application, they codify it, and they turn it into a day one and day two piece of code that will run your application and build a lifecycle around that. So a lot of work happening around operators. You can check all of this out at operatorhub.io, where you can see what's going on in the community. Lots of different companies, over 100 at this point, are building operators to be able to run natively on Kubernetes and on OpenShift. And this means they run consistently on every cloud around the world. You have much more control over them than maybe you do from some native service from the public cloud. So last two things I want to talk about real quick are called service mesh and serverless. Service mesh is a really new emerging technology that's sparked a lot of interest from people that are building microservices. So whenever I'm building distributed applications, it means I'm going to involve the network between my applications. I have to be able to isolate the network where needed. I need to be able to make sure that communication between those is all secure. And so what the Red Hat Service Mesh does as part of OpenShift is this is a native service of OpenShift. Any application can take advantage of it. And not only do we provide the service mesh capabilities, which are based on a technology called Istio, but we also provide visualization and tracing capabilities by using technologies like Kiali and Jaeger to help make sure that developers have great visualization of what's going on, great tools to make sure they can trace and track what's happening with their applications. And then we also integrate that with monitoring and metering services like Prometheus to make sure that the operations teams can know what's going on with these new distributed applications, make sure they're running well, make sure they're performing. So the service mesh technology, OpenShift Service Mesh, is a native service within OpenShift. Again, something you don't have to worry about as an application developer. It'll just be there for you. And then finally, we're seeing more and more developers who are experimenting with this idea of serverless or function as a service. Just focus on the code. Don't worry about anything from the infrastructure scaling perspective. Let the system just take care of that for you. So OpenShift Serverless, again, is a native service of the platform. It's based on a technology called Knative, which is essentially serverless on top of Kubernetes. Again, supports any language because it's container-based, supports any framework. We're seeing more and more companies that are very interested in this. And then what we do from a Red Hat perspective is make sure that it fully integrates into all the other tooling that go on in the OpenShift platform. So developers, focus on your functions, allow the platform to scale them for you, and all of the things you need in terms of visualization, monitoring, metering, all those are just native services that are built around this. So hopefully this gives you a very good sense of how we think about helping developers. We want to bring the best of the open source community into the OpenShift platform. We do all of those integrations for you so that you don't have to spend time fooling around with integrations, worrying about it. Are they going to be secure? Will they run highly available? And then the platform just takes care of that for you. You can focus on your application development and your application integration points. So with that, thank you so much to Vance and his team for allowing us the time today. I'm going to wrap that up. Hopefully we answered a number of your questions about how Red Hat can help you. And with that, I will hand it back to Vance.
Brian, fantastic session. From all the laundry list of features that you provided us here, it's really clear that OpenShift has got a lot of work behind it and getting all of us ready in the app architecture world for the new 2020 decade. So thanks very much for a great session.
Thank you very much.
You know, one of the things that struck me, Brian, is that you've got tons of features in here, but you've also got some design thinking or ways to help developers and folks in the deployment phase. I wonder if you could just comment a little bit about the thinking that's gone in at a big picture level of OpenShift 4 and what you've been seeing among the early adopters.
Yeah, it's a great question. I talked a little bit about how many different groups often have input. The infrastructure operations and security team has concerns. Obviously, the application team does, and architecture and I think what we've ultimately seen is that in order for platforms to be successful, number one, they have to be able to address the needs of a lot of those teams sometimes at a very sophisticated level. So we've always wanted to make sure that the platform is highly secure, it's highly available, it's highly scalable. That really touches on the things that the infrastructure and platform team needs. And then what we've learned is that most organizations, whether they're medium size or large size, have, in some cases, hundreds of applications, in other cases, thousands of applications. We want to make sure that when they come to us and say, hey, we have an integration project, something that's going to take an existing application and modernizing it, we have the tools in place to help them. But at the same time, when another group comes to us and says, hey, we have a chance to really advance the business, if we can build this new application and scale it in new ways, we want to make sure that those tools are there for them too. So while it sounds like there are a lot of features and capabilities on the platform, which there are, in most cases, what happens is we very much try and align the needs of a specific group with some of the subset of those features and capabilities, make sure they're successful, and then we can move on to the next group and help make them successful. So don't be overwhelmed by the number of features. Typically, any group is going to need a subset of them, but they're all there available to sort of help typically broad organizations be able to support a lot of different applications.
Another feature that got some attention, Brian, was your mention of cloud native CI/CD. And one of the questions is very interesting. It says, we're having trouble coping with CI notifications in the environments we have now. Some developers even ignore them. Is Red Hat's approach going to help that streamline so that we can actually keep pace with CI notifications?
We've always long believed, we see this reality in the market, is the companies that are ultimately successful at agile and digital transformation and all the buzzwords, you have to be really good at CI and CD. It's a core competency. The problem that often happens is CI systems sometimes can't scale to all this new demand, new changes. And also developers didn't like the idea that they always had to go to some other group to help run their pipelines. And so for us, I think what we're going to see is this new system is more scalable than previous systems we've seen in the past. So that should help eliminate bottlenecks. The other thing is giving developers direct access to building their pipelines and seeing what's going on is going to make it much cleaner, much more transparent for them to know, hey, are my builds taking place? Are they being done in a timely manner? When can I come back and keep working on them? So hopefully a lot of that notification nightmare will begin to go away as the system becomes faster and they've got greater visibility and transparency into what's going on.
Excellent, excellent. Another theme that I think a lot of our attendees work with is the idea of container orchestration and how to get them to work better with each other. One comment noted your slide, Brian, that talked about you're helping make containers act more like building blocks. So the question simply says, how is Red Hat going to make orchestration of containers even easier?
Red Hat is the second largest contributor to Kubernetes. We very much believe in the technology. We believe it was really important for us to help co-develop it with the community, with Google. So we believe at one level, we've already made Kubernetes much easier by just embedding it into OpenShift. You don't really see it. The developer, you don't have to know a lot about it. And then what we do is we try and spend our time not only building some tooling as the things we talked about in this presentation, but also building learning systems and other things that developers can go read, try out on their own and realize, oh, okay, some of this, I don't have to change anything about how I develop it. And then as I learn just enough about Kubernetes, maybe how it scales or how it can help with a certain type of application, it becomes really powerful. So we've tried very hard to do a lot of the heavy lifting up front to make the system work really well and hopefully hide a lot of the complexity within OpenShift so that as a developer, you don't have to spend your time being a Kubernetes expert. You can keep being an application development expert.
Oh, that's really great. That's really great. Brian, I see time is just about out, but I think we can squeeze one more in. Another feature that caught attention was that web console you talked about. Put that in context for us, if you would. The question here says, is the idea to give real-time visibility to developers? And if so, how would they interact with IT?
We really believe a couple of things. One, you want to make the tools native to the platform so that you're not having to scramble around for things. So first and foremost, yes, the things that you saw will be updated and change and interact real time. So they're native to the system. They get feedback natively to the system. So they're going to have changes in real time. One of the really nice things is these tools being built into the platform. You can allow both the application team to see what's going on, but if there's a problem, IT ops or security, can also just be logged into the system. You can be looking at the same thing because they're all natively part of OpenShift. There's not a whole lot of, hey, what does this tool mean? What does that word mean? Everybody's using the same platforms. So yeah, our goal is make sure that the teams are empowered with powerful tools, visual tools, but also make sure that they're built around cross-functional collaboration in real time. So yeah, all those things are there and available in the platform. The more that you're giving people common tool sets, common terminology, you're able to provide metrics that make sense to both dev and ops, and you're able to use a platform that both groups are looking at it, same data, the same problem space, the same application at the same time. Just breaking down those silos, letting the platform help drive that new behavior has proven to be really important.
Yeah, really excellent, Brian. So we save time for this idea of the operators, the AI ML moving into the Kubernetes and the cloud. Give us a sense of what's happening right now. You mentioned that you had many folks building them. Are they available for people to play with? Are we in a reference architecture phase? Where would you say we are?
So in terms of reality, these things are all being used today, a lot of times in production. So we're seeing Apache Spark, we're seeing things like TensorFlow. A lot of those have been running on Kubernetes now for a while. We're seeing people use them in production. Everybody from UPS using them to make better decisions about how to fill their trucks for deliveries, with everybody wanting one-day delivery. We're seeing Volkswagen is using AI and ML to build out their next generation of how to build autonomous vehicles. So this stuff is very real. It is being used in production by a lot of different companies. And if you go to opendatahub.com, Red Hat has a whole bunch of references and reference architectures for how to get started with that today and how to leverage all the powerful things that are happening in the AI community today on OpenShift.
Fantastic, Brian. I see time has expired with that. Really great conversation, really great features, and no surprise that a couple of comments and questions have come in. What's the best way to go forward? And is OpenShift 4 entirely or as components available for free download or sandbox environment?
Yeah, so I'll give you hopefully 3 very simple URLs to remember for anybody interested in OpenShift. So OpenShift.com is the website, and go find any information you want. If you want to try OpenShift.com, you can go to try.openshift.com and you can get the software. It will help you spin it up on any cloud environment or private environment that you want to. So if you want to try it out, try.openshift.com. And then if you want to learn more and kind of get some hands-on before you try it, you can go to learn.openshift.com. And we have a number of web-based, self-paced tutorials that will just give you an environment on your browser. You don't have to have any equipment. They're free to run and completely self-paced. So hopefully between openshift.com, try.openshift.com, and learn.openshift.com, you should be able to get really smart about this and get as much hands-on time as you'd like to.
Brian Gracely, Senior Director of Product Strategy for OpenShift at Red Hat. Thanks very much for a great session, a really great overview of the status of where we are with OpenShift 4, a really great list of components and features that would help many folks along the development pipeline and operations, and especially for taking so many questions. It really shed some light on some really great features. So thanks a lot.
You're welcome. Thanks to everybody for listening.
And as we love to do here at the Application Architecture Summit, Brian mentioned quite a few resources. We're going to make sure that you take a look at those links to the website and the free trials. They're available here right under the view screen, in addition to some great PDFs and other downloadable material that you can take with you. And secondly, let me just kind of remind you there's so much going on at Red Hat OpenShift these days that we couldn't fit everything. So here's a slide that'll take you to the other assets directly from the Red Hat website. You download Brian's slides, and these links will be live. Thanks again, everyone.